Hi, welcome back. This is Key Skill 2 in Recurrence Relationships. Now we understand what the concept of recurrence relationship is, how we're using the previous answer to generate the next answer. We're going to be looking at some problems, some more exam style problems with recurrence relationships. Question 1, let's get started. Find C given that U3 is equal to minus 36 and we've been given the recurrence relationship here. Well, we've got U1 and we can't go directly from U1 to U3 because that's not how our formula works. It uses the next term, you need the previous term. So what we're going to have to do is we're going to have to stop in the middle and calculate U2. So we're going to go from U1, get an answer from U2, go from U2, get an answer for U3, and let that answer equal to minus 36, and we should be able to find C. So let's get started. So U2, our middle step, must be 3 times U1. So U2 must be 3 times 5C plus 1. And times that out. So now we can calculate U3. Now we've got U2, we can go. So it's 3 times U2. So U3 is 3 times 15C plus 3. Let's tidy this up. 3 times 15 is 45C plus 3 times 3 is 9. So we know that U3 is 45C plus 9, but we also know that U3 is minus 36. So let them equal to each other. Okay, that's U3 must be equal to U3. So let's solve this equation. So we're going to have 45C is equal to minus 36 minus 9. So that's minus 45 equals to 45C. Divide by 45. And C is equal to minus 1. You could put the numbers back and check it to be safe. So you could go back and work out what U2 would be. Let's do it quickly. So that would mean that U2 would be, if C is minus 1, minus 15 plus 13. So U2 would be minus 12. And U3 would be 3 times minus 12, which would be minus 36. This question is a little bit tricky because it says a sequence A1, A2, A3, ... So continuing like that satisfies this recurrence relation. Find A1 given that A2 is equal to 4. So we're going to go backwards now. We've always been using A1 to get A2, A2 to get A3, etc., etc. So we need to work backwards. But let's start by writing down the recurrence relationship that links A2 to A1. So if we think about it, A2, so in this case, K would be 2, must be equal to 2 times, if K is 2, K minus 1 will be 1 minus 1. So you write the formula that links them together, and then you can substitute the 4. So 4 will go here. And we can work backwards to find A1. So divide by 2. So 4 divided by 2 equals A1 minus 1. 4 divided by 2 is 2. And add the 1. So working backwards and basically reversing your recurrence relationship, you can go from U2 back to U1. And again, you can check it works. So let's think about it. If A1 is 3, A2 would be 2 times 3 minus 1. A2 would be 2 times 2, which would be 4. So that's fine. Find A given that x3 is equal to 10 and x1 is equal to 1. And we've been given a recurrence relationship. So as you guys already know by now, we can't jump straight from x1 to x3. We need to stop in the middle and get x2. So x2 would be this. If n is 2, n minus 1 is 2 minus 1, n minus 1 is 1. So this would be x1 times by x1 plus a. So x2 would be x1, which is 1, times by x1, which is still 1, plus a. So x2 is 1 plus a. Now we need to get x3, which is, if n now is 3, n minus 1 must be 2. So it would be x2 times by x2 plus a. Or if you like to think about it more in terms of words, this means the next one is equal to the previous one, bracket the previous one plus a. And you need to times out that bracket, right? So x2 is 1 plus a. x2 plus a would be 1 plus a for the x2 plus another a. So that's the x2. Let's tidy up the brackets where we can. Oh, I'm writing in brackets. Red, let's go back to black. And let's multiply out the brackets. And now we know that x3 is 10, so we can put that here. And now we have a non-monic quadratic equation. So we basically need to bring everything to one side. Okay, so I'm going to start by writing the a squared. It's much easier if you're at a squared, then a plus 1, and I've brought the plus 10 over to the other side, and it's become minus 10. 1 minus 10 would be minus 9. So we need to multiply for 2 times minus 9. We need to multiply for minus 18, add for 3. So we're going to have 6 times minus 3. 6 minus 3 would be 3. Okay, factorize the first two. And the last two. Okay, I'm gonna go from the bottom, and we're gonna have two values for a. From this one, we're gonna have 2a minus 3 equals 0, 2a equals to 3, a equals to 3 over 2. And from this one, you can have a equals to minus 3. So if you guys want to check out both of those, you could say then x1 equals 1, xn equals xn minus 1, xn minus 1. For example, it could either be minus 3 or it could be plus 3 over 2. In the next video, we're going to be looking at how if you've been given the nth term, you can decide if a sequence will increase or decrease, and you can prove that, and how you should write that down on your exam paper. So stick around and I'll see you soon.